parents, teachers, students, to my TPOL. My name is Adrian, and today I will be speaking to you guys about some subjects, topics, and projects throughout each class. So, to get things started, let's add in a little salt, subtract some of that bad taste, and jump straight into math and science, where I've decided to shake things up a bit. Today, for my POL, I've decided to become the teacher and teach you guys about simplifying algebraic expressions. Now you may be wondering, what is an algebraic expression? Or what is an expression? Now, an expression can be any mathematical equation that includes terms, mathematical operations, and integers or variables. And an expression can include both integers and variables. And that's what makes it an algebraic expression. An algebraic expression is basically just an expression that includes variables. So, I've written down a sample problem here that I'll be teaching you how to solve. Before I do that, I'd like to show you some of the work samples that I brought in here for you guys today. The first work sample that I brought in is my POD journal, where I took down a lot of notes about simplifying expressions. Here, I practiced a lot and was able to learn a lot. The second work sample that I brought in are some homework sheets to show how I went from simplifying basic expressions with only integers and small amount of operations to more advanced expressions with both integers and variables and larger amounts of operations. You can check some of these out. Okay, so now let's go back to simplifying this expression. An important thing to know about when simplifying expressions is PEMDAS. And PEMDAS basically just teach you in which order you should do things when simplifying expressions. So, first, we'll do parentheses. Second, we'll do exponents. Third, we'll do multiplication. Fourth, we'll do division. Fifth, we'll do addition. And finally, we'll look to see if there's any subtraction in the problem. So first, let's see if we can combine any of the integers in the parentheses. As you see, we cannot, because they are not like terms. Negative 2x has a variable, and negative 10 does not, and positive 5x has a variable, and negative 4 does not. When this happens, we use something called distributive law, or we multiply the numbers inside the parentheses by the numbers outside. So, if we do negative 5 times negative 2x, we'll get positive 10x, and then negative 5 times negative 10 will get us positive 50. So now, we can do the same thing with the other parentheses. So positive 3 times positive 5x will get us positive 15x. And then positive 3 times negative 4 will get us negative 12. So now, we'll copy everything down. And now we'll move on to look for any exponents. As you see, 2 has an exponent, and it's 2 to the power of 3, which basically just means 2 times 2 times 2, which equals 8. Because 2 times 2 equals 4, and then 4 times 2 equals 8. So we'll turn that into an 8, and then once again, copy everything down. And copying everything down just helps you keep track of what